Section 7.5 is exponential and logarithmic equations. I can solve exponential and logarithmic equations. This is our learning target and what we're shooting for. Big ideas here are logarithms can be used to solve exponential equations and exponents can be used to solve logarithmic equations. Remember, these are inverses and it's how we solve equations based on where the variable is. If we have a variable inside our logarithm, we solve it using exponents. If we have a variable in our exponent, we solve it using logarithms. So it really just depends on where our variable is. Again, if our variable is in our logarithm, we use exponents. If our variable is in our exponent, we use logarithms. The exponential function y equals b to the x and the logarithmic function y equals log base b of x are inverse functions. Any equation that contains the form y equals b raised to the sum number c times x power, where the exponent includes a variable, is called an exponential equation. When we solve these, if we can get them to a common base, we can set our exponents equal to each other, and that's what we did in one of the other sections. So 16, we can rewrite 4 times 4 and 2 times 2 as 2 to the 4th power. We raise that to the 3x power. All I did there was replace the 16 with 2 to the 4th power. 8 is 4 times 2 and 2 times 2. So 8 is 2 cubed. We have the same bases here, 2 and 2, which means our exponents we can set equal to each other. Right now we have power to a power, which means we take and multiply our exponents equal to 3. The only way these two things with the same bases can be equal is if their exponents are equal. So 12x equals 3, divide by 12, and x equals 1/4. Okay, we can plug that back in and double check, and it's going to give us the answers that we need. It's going to be equivalent. Go ahead and pause and try this one. Now, what is the solution of 27 to the 3x power equals 81? Again, let's see if we can get these to have a common base, because if we know the bases are the same, then the only way that our expressions can be the same is if our exponents are equal. So I have 27 is 3 cubed, and that's still raised to the 3x power. 81 is 3 to the 4th power. And again, because my bases are the same here, I can set my exponents equal to each other because that's the only possible way that we can get these two sides to be equal. 3 times 3x with that power to a power means we multiply our exponents equals 4. 9 to the x power equals 4. In order to solve for x, I divide by 9. And I get x equals 4/9. Again, we could plug that back in to double check and it'll work. When we can't get the same base and we have variables in the exponent of the equation, we take the logarithm of each side of the equations. Okay, each side of the equal sign. So here, 15 and 285 aren't going to be ever simplified down to the same base. So what we do is we take the log of both sides. We get log of 15 to the 3x power equals log of 285. Using our properties, we can take that 3x and swing it to the front. Now, to get my x by itself, I've multiplied by 3 and I've multiplied by log of 15. So to get rid of multiplication, I divide. And whatever I do to one side, I do to both. Those cancel, those cancel. I have x equals, sorry, I forgot my 3 there, log 285 divided by 3 log of 15. And again, I swung my 3x to the front as multiplication. And then to get rid of multiplication, I divided by 3 and log of 15 on both sides. To type this in your calculator, you're going to have to make sure you put a parenthesis there and put parentheses around your denominator. So log of 285, parenthesis, divided by parenthesis 3 log 15, double parenthesis there to close your logarithm and your denominator, and you should get approximately 0.6958. Now, to find the solution here, we're going to do the exact same thing. I'm going to show you it in just another way as well. So I'll show you both ways here. We get log 5 raised to the 2x equals log of 130. Swing your 2x to the front, and we're going to have 2 times x times log of 5 equals log of 130. To get our x by itself, we divide by 2 and by log of 5 because both of those things are being multiplied. And x is going to be approximately log 130 divided by, don't forget your parentheses there, 2 times log of 5. Don't forget to close both parentheses, about 1.5122. We can do the same thing here if we switch it to exponential form, and that's why this works. So right now I have log base 5 of 130 equals 2x. If I just switch it to exponential form, divide by 2 to get x. But we have to use change of base anyway in order to solve this in our calculator. Log of 130 divided by log of 5, and that 2 is still in our denominator. So it ends up getting us to the same place because we have to use that change of base to type in our calculator anyway.